So now we're going to go over precision and significant figures. Significant figures is something that I swear chemistry teachers did not make up to take points off otherwise correct answers. Significant figures is the way that we represent precision in our measurements, and it becomes very important when we're doing precise measurements. So any scientific measurement that is recorded is done so in such a way that every digit is certain except for the last one, which is estimated. That means in this measurement of 5.213 grams, this number right here has been estimated or reasonably guessed at. So that last digit contains all our error. Okay, and it also represents the end of our precision. We are precise to this place. Okay, so when we repeat this estimate, this measurement, this is the only number that should change, and it should only change by a small amount. So significant figures, the definition of them is these are numbers that are measured or reasonably guessed at. So reasonably guessed at is what we're going for. Okay, and we should be able to know which numbers are significant or not. So one rule is that all non-zero numbers are significant. So if I had a number like 479 grams, each one of those numbers is significant, and the least precise of that one is right here in the ones place. Okay, so all non-zero numbers are significant. Any number between significant numbers is significant as well. So if I had the number 1532 meters, this one is significant, this one is significant, and as a result, anything between them is significant. So if I change these to zeros, let's say 1002 meters, this is significant, and as a result, these two are significant as well, meaning that they've been measured or reasonably guessed at. Leading zeros is something that is not significant, meaning that they have not been measured or reasonably guessed at. And let me give you an example of that. So if I have a number that looks like this, 0.00517 grams, these numbers right here have not been measured or guessed at. They just give us a sense of scale. So they are not significant. There are only 3 significant figures here in this number. Another way that we can test that is we can express that with scientific notation. 5.17 times 10 to the minus 123 grams. Okay, so these are just placeholders. They give us a sense of scale. They are not significant. They have not been measured. Trailing zeros with a decimal are significant. So what does that mean? Okay, if I have a number like 1.500 grams, this number right here is significant. That last zero past the decimal is significant. It means that this number has been measured or reasonably guessed at. There's a really big difference between that number and this number. Okay, this has its precision all the way to the tenths, hundredths, thousandths place, and this has its error all the way to the hundredths place, which means that this number is 10 times more precise than this one. All right, so these are trailing zeros with the decimal. However, if I had a number like 5,300, and I want to say that's grams, these are not significant. They are just placeholders. The other way that we could express this number is 5.3 times 10 to the 123. And so this shows us that there are only 2 significant figures in here, and all of my error is actually in this digit right here. So it's in the hundreds place. So we're really looking for that decimal. Some authors, your author does not do this, but some authors would do this to make that last zero significant. They would go 530 and put a point there. And what that does is that tells the reader that this is a significant figure. Your book does not do that, but they want to make you aware of it. Another practice is to put a line over it to show that that number is significant as well. So generally speaking, look for the decimal points to tell us whether or not numbers are significant. All right?